There is a common question among those intelligent enough to discern the current weak mode of the Sun. As the last solar minimum ran long and low, followed by the current weak maximum, speculation abounds about the entry into another grand solar minimum. We know that temperatures drop during a grand minimum, but how much? And what else should we expect? These are driving concerns. So let's look back at history and see what we can discern about the coming solar cycles. The first thing we have to note is that the best temperature comparison we have shows a marked decline in temperatures from a normal solar cycle, and NASA chose 1780 as that time of reference. But here's something interesting. Looking back at the entire grand solar cycle, 1780 appears to be one of the weaker cycles and about half as strong as what we've experienced in recent decades. The inability for the IPCC to accurately predict global warming has been purported to be due to their ignoring the solar influence completely, which they do, and it hindered their ability to forecast the future, especially during this latest global cooling period of the last decade, creating the so-called global warming pause. The best multi-grand cycle reconstruction shows that the solar activity spike during the period of global warming was not only the modern cycle grand maximum, but likely the highest solar activity of the last 3,000 years. Given the best approximations of previous cycles, it is indeed the highest activity and lasted much longer than the maximum spike should last. The experts claim that this maximum is rare, and perhaps a unique event among our observational and reconstructed data, both in intensity and duration over the last 3 millennia. Seems like a bad thing to ignore if your current models have failed for 2 decades straight. But what about this current pause, the cooling? About a decade ago, the Sun changed gears. It began weakening faster than any decline on record for the past 9,300 years, and appears set to bottom out like it did 400 years ago in the Maunder period, the last grand minimum. Chowdhury 2013, the single best reconstruction of the last 11,000 years, goes by data reconstruction and solar dynamics modeling. The modeling math shows the grand minima come every 350 to 450 years, with observational data suggesting we go quiet and cold every 400. Right in the middle. Let's look back to that time, the mini ice age that capped off the much longer little ice age, and which was the icing on the cake for many disasters on this planet. 400 years ago puts us right on track for the minimum, and the primary concern, via cold weather and droughts, is famine. In the 1630s, 2 million people died due to famine in India. Beginning in the late 1640s, huge portions of Europe developed famines. In the early 1660s, India went 2 full years without a single drop of rain. 1680, famine killed 80,000 people in Sardinia. The famine of the 1690s killed 15% of the population of Scotland. 2 million dead in France during that same period. Later in the decade, more than 100,000 people died in Sweden and Estonia. And at the turn of the century, 2 million more people died due to famine in India. Just a few years later, Eastern Prussia lost 40% of its population to famine. Given the cold NASA has identified between a grand minimum and a normal or slightly weak solar cycle, what sort of shift would we experience coming off the grand maximum of the age of global warming? Most scientists still refuse to even consider this data, let alone this one. And look how quickly many of these drops occur, and our current weakening is faster than those. We can expect colder temperatures, maybe not a full-on glacial period, although we are overdue for one. But the bad winters of the past few years, like 2010 in Europe or 2013 in North America, will become more prevalent. As the sun loses steam, the planetary storms are getting worse, with records falling regularly. How long before travel and commerce are interrupted? How long before agriculture suffers like it did 400 years ago? How long before the plagues and disease that come with famine rise again? The answer is not so simple, but we certainly know where to look. Sure, we don't have $27 billion per year to incentivize scientists to study this like they do with carbon emissions, but for those who truly care, there is no need to compensate for diligence.